I'm now going to do a practice problem that's a continuation of the one that we did looking at the rate law of a dimer. And so previously we found the rate law for a dimer reacting with hydrochloric acid to form hydrogen gas. And we learned that it's equal to a rate of 6 times 10 to the negative fourth inverse seconds times the concentration of the dimer to the first power. The overall order of this reaction was 1, and the order with respect to the hydrochloric acid was 0, and we have our rate constant everything. So this problem gives us an initial concentration of our dimer. It's 2.5 molar. And we need to know how much is left after 60 seconds of that dimer. And so the important information I've kind of pulled out here on the side. And what it tells me, whenever I see like what is the concentration at a specific time, it tells me I need to use my integrated rate laws. And so I'm going to need to use the first order integrated rate law. And I'm using first order because that's the overall order of the reaction. All right, so let's do this and figure this out. So first I'm going to write out my integrated rate law with the information that I have. So I'm going to have the natural log of my dimer at the time I'm interested in, so 60 seconds. So I put a little sub 60 divided by that initial concentration. So I put a little 0 to say that it's the initial time. So time equals 0. That's going to be equal to negative k times t, our time. So I'm going to go ahead and start filling in the information that I know. So again, natural log. I don't know that concentration at 60 seconds. That is what I am interested in. Fe. My initial concentration is 2.5 molar. That's going to be equal to the negative of my K value, which was right up here, 6 times 10 to the negative fourth inverse seconds, times my T, which is 60 seconds. All right, so now my goal is just to solve for this concentration right here of my dimer. And so plugging this all into my calculator, I'm going to get a value that's 2.4 molar. All right, and just plugging this into my calculator, I'm going to get a value that is 2.4 molar. So this is the concentration after 60 seconds. So it doesn't decrease too terribly much, so it's a little slow.